All right, today we got applications of normal distributions, applications of what we did the last couple of days, taking normal distributions and finding some stuff out from them. This section presents methods for working with normal distributions that are not standard. That's when the mean is not 0 or standard deviation is not 1, which is what we worked with earlier in the year. All right, before we started learning about standard normal distribution, we just did normal distribution. So the key concept is we can convert any normal distribution to a standard normal distribution by standardizing it by using what's coming next, and that is the z-score. The z-score converts values that we used to use into z-score so we can use our table or a calculator or StatCrunch to figure out what we need to look for. Also, make sure round z-scores to 2 decimal places, as you know from the tables yesterday. That's what we're going to use all the time, is 2 decimal places. And the reason we have to do this is because when we did this before, earlier in the year, all we did was values that worked out great with what our standard deviation was. Z-scores allow you to go in decimal units of standard deviations. Like you can find out what's 1.57 standard deviations away. Instead of just like, before we did 1 standard deviation or 2 or 3 and that was all. Now you can do all the decimals as well. So that's why this is so nice to be able to do. Okay, all we're going to do to convert it, this is what we did earlier in the year, the first picture. That was our normal distribution, where we put the mean in the middle every time. We put an x value. That was always the standard deviation value. Today, and starting yesterday really, we did the z-scores, that's how you find the z-score. There's our formula. So what's going to happen is our mean is going to be 0 all the time, and the z-score is going to be how many standard deviations away from the mean. I will say this. Z-scores on this side of the mean are going to be positive. Z-scores on this side of the mean are going to be negative. Standard normal distribution is standardized because the mean is always 0 and the standard deviation is always 1. Procedures for finding the areas, pretty much the same as yesterday. We're going to draw the curve, label the mean and any specific values, then shade the region like we did, the probability you want. For each relevant value x, that's a boundary, find the z-score for your x value by doing x minus the mean over standard deviation. And then either use a computer or a calculator or your table to find the probability. So all we're adding to yesterday is really finding the z-score first and then using the same software we used yesterday. All right, let's look at an example. This says Tall Clubs International, that's a neat club, has a requirement that women must be at least 70 inches tall. If you're not sure what that means that each woman must be 5 feet 10 inches tall, pretty tall. Given that women have normally distributed heights with a mean of 63.8 and a standard deviation of 2.6 inches, find the percentage of women who satisfy the requirement. So what I did, I went ahead first of all and just found the z-score. You're going to need to do that pretty much every time. So I found the z-score. To be in this club, you have to be over 2 standard deviations away from the mean, which automatically puts you as, unusual. So draw the normal distribution and shade the regions, which I did. So there's our picture. We want bigger than 70, which is there. Notice that was our normal distribution with that mean and that x. What I did is I put the standardized mean, which is 0, and our z-score 2.38. And I need to the right of 2.38. So there's the actual calculation. I already did that. And I looked it up, and it gave me this right here. It gave me 0.0008656. So what we can say is less than 1% of all women meet that requirement that can actually join the tall club. So very rare. Okay, finding values for known areas. Now we're going backwards. Okay, first of all, make sure you don't confuse z-scores and areas. Z-scores are the horizontal axis. They just tell you how many standard deviations away you are. Areas are the probabilities or the regions under the curve. All right, that's what we're shading every time, are the areas. Make sure you choose the correct side, left side, right side. If it's negative, if z-score is negative, it has to be on the left. Positive must be on the right. Areas, which is the same thing as the probabilities, are positive or 0 all the time. Don't ever give an answer for a probability that's negative. You know that. Has to be, probably if something can't happen is 0, so there's no way it can be less than 0. Let me show you an example of this. All right, it says when designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4 inches. So when they build airplanes, they don't think about the tallest people in the world. They try to think, okay, let's make it to where 95% of the men can fit in it, because usually if 95% of the men can fit, that means most of the women can also fit, at least 95% of them, if not more. So I drew it, drew the picture first, and there's my area. I want 95% in here of men. So the mean is 69.5. The X, I don't know. That's what I'm trying to find out. So what I did is I standardized it with Z is 0. And I had to look up what it is. I looked up this in my inverse norm or on technology or whatever, and it told me what the Z-score was. It told me the Z-score was 1.645. Let me show what we're going to do with that. So I took that 1.645. This says the same thing in the last part. I just retyped it right there. So what I did the Z-score. There's my Z-score formula. But what I need is I'm trying to figure out what my X is. So I solved it for X. I moved I multiplied both sides by the standard deviation. Then I moved the mean to the other side and got this equation for my X. So to find X, I'm going to do my Z-score times my standard deviation, which I did right here, add it to the mean, which is right there, which gave me 73.4. So that's telling me that 95% of the men are 73.4 inches or lower. And for your information, that's 6'1 and a half. All right, so almost 6'2 or shorter. So as long as you're that tall, 95% do fit in there. And if you're bigger than 6'1 and a half, then you may bump your head on the top of the airplane. So that's all we're doing tomorrow, and we'll work with it, make sure you get it better. But make sure you got good notes on this, and hopefully it wasn't too bad. See you tomorrow.